The project consists of construction of 5 numbers of pedestrian bridges over outfalls of varying spans and widths, includes both concrete and steel structures. The 4 bridges are over outfall 1 to 4, and 1 bridge over the Phuentsholing River. The bridges over the open outfalls are steel bridges of rectangular hollow section of grade YST 310 according to is 4,923. The members, which are prepared in the factory, comes up with all the tests carried out, and in the field the sections are cut and measured with reference to the drawing and design and welded together. There are 3 types of welding: gas welding, arc welding, and electrode welding. In this project the members are welded using arc welding. Arc welding is the most preferable when it comes to steel. Gas welding cuts up the section of the steel in the process, which affects the quality of steel unlike arc welding. Arc welding involves creating an arc between the electrode and the workpiece. The heat is generated by the arc melts the electrode and the piece together. The spacing, thickness, and the type of weld is all according to the specification from the IS Code 816. The painting process of the steel members are then carried out. The members are first cleaned and surface treatment is done to remove the rust and foreign materials, after which the primer is applied to prevent the steel from corroding and also act as an adhesive to hold the paint. To check if during the welding the electrode is penetrated towards all the piece, NDT is carried out. The test requires a penetrator, remover, and a developer. Before the test is carried out, the weld is cleaned and dried to remove any foreign materials, after which the penetrator is applied and left for 5 to 25 minutes. Excess penetrator is scraped out and using a remover it is removed. A white developer is applied on the weld and is observed for cracks and spaces. The weld is approved if there are minimum cracks developed. The bridge over the Phuentsholing River is to be designed and built as a traditional Bhutanese timber bridge. Before the foundation is laid out, a 150 mm thick compacted stone soling and 100 mm thick leveling concrete is poured to level the surface with the pre-existing reinforced concrete diaphragm wall, after which the foundation of concrete M40 is poured up to a height of 1,000 mm. The reinforced bars should be applied with water to remove the foreign materials on it. The side walls of the abutment are masonry structure. In masonry structures, it involves the 3 main factors, which consists of 1. Arrangement, 2. Mortar, 3. Size of stone. Up to a height of 3 meters, random rubble stone masonry is provided, after which squared rubble masonry is provided till deck height. The main difference between RRM and SRM lies in the arrangement and the shape of the stones. Rubble masonry involves irregular pieces of stone, which allows the mason to use a variety of stone sizes and shapes. In coursed rubble masonry, the mason arranges the stones in rows of equal height. In some forms of coursed rubble masonry, the stones are in a roughly square or polygonal shape. In a variety of patterns, random rubble masonry involves a free-form arrangement of stone. The rubble masonry, in which the face stones are squared on all joints and beds by hammer dressing or chisel dressing before their actual laying, is called squared rubble masonry. The square rubble masonry, in which chisel dressed stones laid in courses, is called coarse square rubble masonry. This is a superior variety of rubble masonry. It consists of stones, which are squared on all joints and laid in courses. The stones are to be laid in courses of equal layers, and the joints should also be uniform. Vertical joints shall be staggered as far as possible, and should not exceed 200 mm depth. All joints shall be full of mortar. The maximum thickness of joints shall be 20 mm for random rubble and 10 mm for square rubble. A cement mortar of grade MM8 is used to fill the joints and the gaps between the stones arranged. Higher the grade of concrete, more is the compressive strength. Since the masonry wall is to be covered with soil and subjected underground, cement mortar of grade MM8 is used. According to IS 2250, where soil is saturated with water. Masonry mortar of grade MM3 shall be used, but in no case shall the grade of mortar be less than MM